On this page, we'll create a scatter plot of our own, and then we'll find the correlation coefficient for our data. 4 college students were asked how many hours of TV they watch on average per week, and what is their average GPA. X represents the hours of TV watched. Y represents the GPA. Now that should make sense because we want our dependent variable on the vertical axis, and it could be reasonable to assume that GPA depends on hours of TV watched. Okay, I want to plot the data points as coordinate pairs. First, I'll just transfer them over to this vertically oriented table. The 8 and the 4 have to go together because they're a pair. Let's see, 16 goes with 3, 14 goes with 2, and 30 goes with 1. So we'll go over to 8 and then up to 4 to form our first pair, to form our first dot. We'll go over to 16, up 3. There's our second dot. We'll go over to 14 and up to 2. And then let's go over to 30. And we'll stay at 1. There's our scatter plot. Now if you have trouble drawing your own scatter plot by hand, you do have the option of using technology as an aid. I'll go over the steps of how to make a scatter plot on Desmos.com. So on Desmos.com, we'll want to hit plus to add a table. Then just copy your data. And that's all you really have to do. We'll just go over to the graph at this point, and we'll zoom out so that we can see our data. Okay, there it is. We have the option of just rescaling the axes by hitting the wrench here. So our y-axis really needs only to go up to about 5. And we can just start at maybe -1. And we don't need our x to go all the way to 118 because our largest x is 30. So let's try that. Okay, that gives us a little bit better scale. That's great. Now we can see our scatter plot. And it looks just like what we had drawn. Do you think the correlation here is going to be low, moderate, or strong? Well, there's some kind of best fit line that goes through the data. And all the dots can't possibly be on that line. There's deviations from it. So, I might guess moderate to strong. Is the correlation positive or negative? Because it's sloped down, it's negative. Would you say the R value is closer to 1, 0, or -1? I think it's going to be closer to -1 than anything. Can you estimate the R value? I'll say perhaps negative 0.7. I think that the data is fairly linear, but it's not a perfect line, certainly. Now we want to find the R correlation coefficient, and I'm going to show two ways of doing it. First, I'll do it the easy way, by technology. Just go back to Desmos, and we'll enter in a new box this formula. Y1 tilde mx1 plus b. That is the general equation of a line in slope-intercept form. In this program, though, we have to use ones as subscripts of our variables because those are used in our table. Also, this program only accepts the tilde for the regression lines. You can't put equals, so that's something to watch out for. And as you can see, the R correlation coefficient, it's a little bit stronger correlation than I had originally predicted. It's about negative 0.89, which is closer to negative 1 than I thought. So that's the easy way to do it. You can also do it on TI-84 calculator and the TI-30X2S calculator as well. So our answer here is negative 0.89. However, we also want to be able to find that result on our own, using the formula for the correlation coefficient shown below. It looks a little scary at first, but it's just an assembly of several sums, and we'll use a table to calculate our sums. We're going to need a column for x squared, y squared, and x times y. That's all we'll actually need. So first we square the x. 8 times 8 makes 64. 16 times itself makes 256. 14 squared is 196. And 30 squared is 900. Now let's square the y values. We get 16, 9, 4, and 1. Now we have to multiply x times y. So 8 times 4 makes 32. 16 times 3 makes 48. 14 times 2 would be 28. And 30 times 1 is 30. Now we need to calculate the sums of all these columns. The sum of x is 68. The sum of y is 10. The sum of x squared is 14, 16. The sum of y squared is 30. The sum of x times y is 138. Now, if you wish, you can write those sums down. Just for reference. Because we now have to plug those sums into their places in the R correlation coefficient formula. what I'm going to do is I'm going to rewrite the formula, leaving empty parentheses wherever a variable is. Okay. I left an empty space for n. What is n here? N is the number of dots that we have. It's the number of pairs. There are 4 pairs. These are the 4 pairs. 1, 2, 3, and 4. That's n equals 4. So put a 4 in wherever n is in the formula. Here we need the sum of x, y. That's 138. Over here we need the sum of x, which is 68, and the sum of y is 10. The trickiest part is the denominators. There's a difference between the sum of x squared and the sum of x squared. Here, the square gets done before the adding, so they're actually talking about the 14, 16 there. But in this one, the sum gets done before the squaring, so they're talking about the sum of x, which is 68. The sum of y squared was 30, and the sum of y is 10. So when you're calculating this on your calculator, I recommend just doing the numerator first, getting a number, and then writing that down separately. It's negative 128. Then you can put a square root for the left side and a square root for the right side, and just calculate that part of the denominator first on calculator. It's 1040. And then calculate this right side on calculator, and that's 20. So now it'll be fairly easy to plug into calculator. All you need to do is just negative 128 divide by the square root of 1040. Close the parentheses and then do divide by again, 20. Type it into calculator just like that, and you get the correlation coefficient that Desmos had found. Negative 0.89. As x increases, does the value of r imply that y should tend to increase or decrease? It's negative. So, as x increases, y tends to decrease. What does R tell us in the context of the data? Here's where we want to relate it to the situation that was described earlier. As the number of hours of TV watched increases, this data suggests that GPA tends to, as the number of hours of TV watched increases, GPA tends to decrease. Keep in mind that that's just based on these 4 data points. It doesn't mean it would always hold in all situations. It's just that that is the trend we observe in this data set.